400,000 kilometers of X-ray glow. First time in history, they pointed an X-ray telescope at Atlas and discovered its radiating energy across a region larger than the Earth-Moon distance, in a wavelength no interstellar object has ever been detected in before. The spectrum shows chemical elements at excess levels that raise serious questions about what's actually generating this emission. This is the first interstellar object ever detected in X-rays in human history. Not ʻOumuamua, not Borisov, only Atlas. JAXA's X-ray imaging and spectroscopy mission, called XRISM, conducted a target of opportunity observation between November 26th and 28th. And if it wasn't critically important, they wouldn't have adjusted the satellite's altitude 14 times over 17 hours to keep Atlas centered in the field of view while it drifted across the constellation Virgo. The soft X-ray imaging telescope Xtend captured images spanning 3 million kilometers on a side, revealing faint emission extending 400,000 kilometers from the nucleus. That's a massive energetic halo surrounding Atlas, radiating in wavelengths that require high-energy processes to generate. Something is pumping enough energy into the gas and particles around Atlas to make them glow in X-rays across distances that dwarf planetary scales. The natural explanation exists, and it's straightforward. When solar wind particles carrying electric charge collide with the gas plume surrounding Atlas, they exchange electrons with neutral atoms and molecules in the coma. This charge exchange process releases energy as X-ray photons, and we've observed this phenomenon in solar system comets since 1996 when comet Hyakutake first showed X-ray emission. The process is well understood physics that happens whenever ionized solar wind meets neutral gas clouds. But the spectrum shows something that demands a closer look. The Xtend detector measured excess emission components associated with carbon, nitrogen, and oxygen beyond the background levels from the Milky Way galaxy and Earth's atmospheric glow. These aren't just trace detections. They're marked excesses indicated clearly in the spectral data. Excess emissions beyond background aren't typical for standard charge exchange interactions with solar wind. Remember that Atlas was hidden behind the sun at perihelion on October 29th, when it should have been at its brightest and most active. XRISM couldn't observe it then because the satellite can only point at targets more than 60 degrees away from the sun. These X-ray observations came a full month after perihelion, when Atlas should theoretically be dimmer as it moves away from peak solar heating, yet it's still generating detectable X-ray emission across 400,000 kilometers. XRISM carries two instruments. Xtend captured the images, showing the spatial extent of the X-ray glow. Resolve performs high-resolution spectroscopy that can precisely measure the energies and identify the specific atomic transitions, producing the X-rays. The preliminary analysis focused on Xtend imaging, but the Resolve spectroscopy data will provide detailed information about exactly which processes are generating these photons and whether they match the expected signatures of solar wind charge exchange, or if there are additional components that can't be explained by that mechanism alone. The research team ends their report with a pointed statement. They write that it would be particularly interesting to check if there are any other X-ray features different from the expected signatures of charge exchange reactions with solar wind. That's not casual language. They're explicitly calling for other research teams to verify whether the X-ray emission from Atlas contains unexpected features beyond what natural processes should produce. JAXA wants independent confirmation that what they're seeing fits the natural model, or if there's something else happening that demands explanation. This detection adds another layer to everything we've been observing about Atlas. Multiple jets that maintain collimation despite rotation. Anti-tail pointing toward the sun regardless of direction of travel. Swarm of trillion non-evaporating objects maintaining formation. Industrial metal ratios and organic chemistry concentrations higher than normal comets. Non-gravitational acceleration requiring course correction to hit Jupiter's Hill radius, and now X-ray emission across scales that require significant energy input to generate. Each observation by itself might have a natural explanation. The X-rays could be standard charge exchange. The anti-tail could be unusual ice sublimation geometry. The swarm could be rocky fragments. But when you stack observation after observation, each one pushing the boundaries of what we've seen before, the cumulative picture becomes harder to explain within familiar frameworks. JAXA wants other teams checking for unexpected X-ray features. What else is Atlas hiding in wavelengths we haven't fully analyzed yet? The first X-ray detection of an interstellar object just opened another window into understanding what this visitor actually is. And the spectrum is showing excesses that suggest there might be more to this story than solar-wind interactions alone can explain.